And today we are going to talk about some feature related to functional programming, and that is not as easy in Java. Okay, Java does not support it well, so that's why recently more AI computing is moving toward Python. And then if acceleration needed, then people use the C++ or using the CUDA, the NVIDIA CUDA package to do acceleration. So at the end, AI still depend on the processor a lot. Still depend on the processor a lot. Okay, we're about the noontime now. So first thing is still, I would like to go over any question that student has. Okay, so anybody has a question on the homework or whatever question you have, please just raise your question. Okay.
I have a question.
Yes, go ahead.
So on the first programming example, we had to get the current date and time.
Yes.
But I didn't understand what it meant by it must be the time when you write the program.
So it's runtime. You cannot insert a number into there. That's what it is. So you must use the program to detect the time. You cannot use put in some number into it.
Oh, I did both just in case.
Yeah. That's what it is. It means that you need to get the time. Get the time. Actually, in the project one, we also use it because you are going to get time. You are going to get time. So basically, you need to use the CPU time. You cannot use you cannot put some like generally 13, 20, whatever days and time, and just put it there and just try to print out something. That's not what we want. We want you to measure the time, measure the system time. Okay, good question. Any other question?
Actually, I was going to say, I think the confusion might have been that on the PDF for the assignment, it says the time that the program's written at, and on the week 2 section of Blackboard,
Yes.
it says when it's run at.
Yes, just need to read the system time. Yeah,
Okay.
just need to read the system time. Yeah. Okay, any other question?
I had a question on project 1.
Project 1, performance measurement. Okay.
So it says all sorting algorithms must be coded by the student and not to copy any sorting programs from any other.
Yes, that means that you need to write your sorting algorithm. Do not copy from any source.
But
okay, let's assume this. Okay, let's assume that occasionally. Let me do it once. Okay. Let's assume that right now, actually, I need to measure the performance of a bubble sort. Okay, bubble sort. So let me write a bubble sort. So basically here, I need to write a bubble sort. Okay. So I want to buy a bubble sort. So you cannot say copy a bubble sort here and then measure the bubble sort. That's not something we want to have. So you need to actually create a bubble sort. Let's call it BS. Okay. And then you get an array. Okay. And then write your program here, right? Write your program here. And then later you need to run your bubble sort, right? Okay, let's assume that this is the program we want to write for the time being, right? And then let me actually have the data. Let's assume that we have an array data A equals A 1, 2, 3, 4, 5, 10. Okay, let me put in 1 to 10. Okay. So A1 is actually, let me scramble it, okay? So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, good. So this is the data I have, and I want to do sorting, and then I want to actually sort the data. Okay, and later I want to print it. So let me print the array A. Okay, so you need to set up this environment then write your own bubble sort, okay? So when I say that, okay, I don't want you to copy from somewhere else, so do not do this, okay? Do not do this. So let's actually go to somewhere and then bubble sort. I don't want you to do this, okay? And grab some bubble sort algorithm. Let's just don't look at this. Grab some bubble sort algorithm from someone else. Okay, someone may do this, okay, and then I don't know, maybe Python, maybe Python 3, and then actually copy here, okay, whatever, and pass to the. No, I don't want you to do that, okay. I want you to actually rewrite it by yourself. But let's assume that here we do have a bubble sort that we want to do, right? So basically, let's assume that you have a 3, 5, 1, 4, 2. You want to do bubble sort. So bubble sort theory, you need to remember it. So basically, it's a sinking sort. You want to the heaviest one to sink over here, right? And every time you do compare and swap, compare and swap, compare and swap. Okay, so your heaviest location would be this one, right? And then you do swap, 3 and 5 swap, and then actually 1 and 5 swap. Okay, so 1 and 5, so lighter one move this way, okay? 4 and 5 swap, 2 and 5 swap, okay. So after the first one, it becomes 3, 5, 4, 2, 3, 1, 4, 5, 4, 2, 5, okay. Let me clean up the garbage, okay. So after the first one, that we can be sure is that this 5 is the heaviest one, so it stay here. Second one, so that's the first iteration. Okay, first iteration like this. Okay, first iteration after you finish, you get this one, 3, 1, 4, 2, 5. Okay, and 5 is the heaviest one. Second one, you will go to the second rung. So you go to the second rung. So you go to the second rung. So you do swap. So second rung, let me use different colors. So 1 swap with 3. 3, 4 no swap, 2 and 4 swap. So here, second one you get this, right? Third rung, you have 1, 2, 3. Okay. Fourth rung, no swap, but actually fourth rung you will finish with 1, 2. Okay, and you will finish. So this is the complete bubble sort. Okay, complete bubble sort. So your heaviest one starting from here to here, right? That's your outer loop. Okay, so let's do this one. Let's actually do for integer. Okay, in range, right? Your range. So your range is starting from 1, right? I'm sorry, starting from the last one. The last one actually is actually length of the array. Okay, -1 down to 0, 0 not included. Okay, the last one will be 1. Okay, every time you do -1. So that is your outer loop. Outer loop index. Okay, and outer loop index representing what? Representing the heaviest location, right? Every time the heaviest one will stay there. Okay, so that's the outer loop. Now in the loop, you start to do swapping. So for J in range, what range? Let's look at it, okay? So next one, you are going to have the window of the 2. Okay, let me erase something. So let's just look at this one, okay? So every time you have a window of the 2 until your last window of the 2 is your last comparison happen on here. So your J starting for window of 2 here, J from 0 down to this one, right? Down to this one. So your J starting from 0, okay? And the last one, actually should be less than this. So it actually is actually less than length of the array minus 1. Okay. This one actually is down to the array minus 1. So that's your inner loop. Okay. So your inner loop is like this. And then after that, you try to have every I and j. Okay, you have a window of 2. So you say if arrays j, okay, is greater than array of j plus 1, then you need to swap. You need to swap these two numbers. So temporary number is actually array of j. Okay. Let me see. You swap the two numbers using rotational swap. I have an error. This is a prime point. This one is a rotational swap. Rotational swap means you have A and B, A equals 3, B equals 4. So you back up your A to some number called 10, right? So this one becomes 3. And then your B assigned to A, so this one B, that's the 3, it's become 4. And then later your 10 assigned to B, you become 3. Then you finish your swap. This is rotational swap, okay? Whenever your J and J plus 1 out of order. So for this one, you have a 3, this one you have 2, you have to swap these two, okay? So the inner and outer loop is set up in this way, and then you swap it and then you print it. So let's see, save, run it. It's sorted, okay? It is sorted, so here I use a sample of 10 number, and then you need to try to generate 100 number, 200 numbers, whatever number. You need to create your own pattern. You need to create your own pattern. Is that okay?
Yeah. So I was just saying, like, say I don't have double sort or insertion sort memorized. How would I go about, like, creating the sorting algorithm if I don't, look it up?
You
Because
don't look it up, but you don't know it. For example, you never study, right? So what I suggest you is that, okay, it's okay you come to here to study,
Mhm.
and then close your eye, come back to write. But do not do this. Do not do, hey, let me do this copy.
Yeah,
pass.
definitely.
You know what I'm
But
saying?
yeah, I understand.
The purpose is want you to learn this.
Uh-huh.
Okay, but I cannot say that everybody really learned Python sorting before. So what? So you can come here to study it. Okay, this is what
Mhm.
how it works. Okay, finish. Come back to write. And you come back to write, you may fail, right? Then you clean it and go back to look at it again.
Uh-huh.
And
But
until you can rewrite it all by yourself without consulting other source. This is the training for coding. Is that okay?
so are there other ways to write bubble sort other than this way, or is this only one way to write it?
There are many ways, I should say, but you pick one way that you prefer.
Uh-huh.
So there are millions of ways of doing different kind of sort. So selection to even selection sort, there are different versions. I do not say that you must follow which is version, but one thing is that do not copy.
Okay, yeah, that makes
Yeah,
sense.
that's the keys, not the key. And then you also need to know how to generate a random pattern. 10 number, this one is okay, you can key in. How about 1,000 number? How can you do 1,000 number and from 1 to 1,000? That's a question, right?
Yeah.
You do shuffling.
Okay. All right.
And
Thanks.
then you can search for internet to see where there are shuffling algorithms. So you basically, shuffling means that start to generate a array or a list of 1, 2, 3, 4, 5 to 1,000, right? And you shuffle this one so that it actually randomize somehow, and then you sort on this pattern. Is that okay?
Yep. Uh-huh.
Okay, that you need to be able to prepare your own test patterns. Is that okay? So
Yep,
key
thanks.
point is to do what? To do try to train yourself for coding. Okay, most of you are either college junior or senior student, right? So you may need to do LeetCode, right? You may need to do LeetCode. You may need to do this code signal test, right? So we are just trying to give you more chance to practice your coding. Is that okay? And if you try to copy, well, where I know it, I may not be able to know it because how can I test everybody the code? I will test your code anyway, but I cannot actually say that this is a copy or not copy, right? Unless that I check internet for every version, but you will be losing your opportunity to learn. Okay, is that okay? So try to memorize how the algorithm being done. Okay, try to do that. This is I should say, a good chance to review your algorithm and coding, and it's related to language anyway. Okay. Any other question? And we ask you to do chapter 1. There's a measurement of time, right? And later here, we apply the measurement of time. And the reason why we want to measure the time, just because what? Because this is the way to measurement the efficiency of the algorithm, right? Starting time, ending time, you will see how to do study, okay? It's helping you to do study, how you do study to analyze the efficiency of a algorithm. There are two ways you measure the algorithm, efficiency of the algorithm. One way is you come up with your big O notation, right? The other one is using the measurement time. Okay, big I notation is better in terms of estimation the growth rate. When the n go bigger, is your program scalable or not? But real-time estimation give you the better sense of how long your program need to be finished. So performing real-time operation measurement is also making some sense. Sometimes your problem don't care about growth rate, but do care about the latency. Okay? Is that okay?
So in addition to doing these different test cases, are we also supposed to create a chart like you created on
Yes.
on the
Yes.
bottom?
That's a project, right?
Yes.
So assignment is just need you to do program. I don't need you to write report. No report on project, on the assignment. But project means project. Project means you need to report the performance. You know what I'm saying?
Yeah, so we need to create this chart as well.
Yeah, this one, yes. And that's the purpose. Also want you to be able to prepare for the result, yes.
Okay, all right, thanks.
And programming assignment like week 1, week 2, week 3, whatever the program assignment, no, not needed because you give me the program. Okay, usually what happens is like, let me show you. I download your program. Okay, so some student, whatever. Okay, this one Dennis. Okay, and program assignment 2. Okay, I download everything here, right? And then I don't see whatever he say in the program assignment. I don't care. Okay. I don't need to know that, just come here and run. See what's your result. Okay. I don't care what you say here. Whatever so beauty chart you say, I don't care. I only see if your program work in the programming assignment. Is that okay? This I just check here. I don't care about if you give me the extra writing, copy the result onto the PDF. I don't care. I just look at whether your result is right or wrong. Okay, these are programming assignment, but the project is different. Okay, project that we require here is that I do really need you to do study, and if you, okay, so there are some charts I want you to do, but if you analyze in more detail, they are also welcome. Okay, sometimes I'll give extra bonus point if some student go beyond the minimum requirement. Okay.
I had a question.
Yes, go ahead.
So yeah, about like the homework that was due last night. I kind of put all 5 problems into the same file. Is that okay?
That's
Or-
okay. That's okay,
okay.
but usually I suggest to be separate.
Okay. Okay. So going forward, I'll just do
Usually
that.
something like this is welcome. Because I just go and run each one.
Yeah.
Finish that, I go and run this one. Right? You know what I'm saying?
Okay.
And if you give me 5, then I need to, in the same file, then it's actually, I need to move around here to check.
Thanks.
Right? Thank you. Any other question? We have some coffee, okay. Any other question?
Actually, on that project, I just thought this. For making that line graph, how many data points would you recommend minimum?
I think 5 point maybe, yeah.
Okay.
But the more will be welcome.
All right.
And remember, this one is a log chart, okay?
All right.
Log chart is a log chart. So NumPy, welcome, okay? If you use NumPy, welcome. You use SciPy, whatever tool, Matplotlib, welcome.
Okay.
Okay,
All right. Thank you.
no problem. It's also a practice for you, right? We want you to be more, be able to use Python efficiently. So you see that, okay, we are doing programming language. So project 1 is reviewing your sorting algorithm, right? So it's an algorithm study. Project 2 is on recursion, a tree structure. And it is also try can be used for dictionary. So I need you to really understand how to use try as a dictionary, as the Python dictionary and the internal data structure. So it's a class design. You need to know OOP well. You also need to know about dictionary well. You also need to know about how to use dictionary well. Okay. So one project for data structure, one project for sorting algorithm, and then term project is an open project. You need to use the data structure and algorithm to do language translation. That's how we have 3 projects. Is that okay?
Yeah, that's good.
The key of the main theme of this course is called what? Structure and the programming and the interpretation of computer program. So this one actually is to knowing about the mechanism of computer language, right? And computer language programming language, the key is translation. Okay, computer language is the key is translation. So translation is what? You get one language number 1, you get output language number 2. Right? That's what you really want to know. And then you design your language, your Unity language. And then the whole thing, optimally, this one will be a compiler. That's a different course. But right here, you need to know about the mechanism of a programming language. That's a core idea that we want you to learn in this course. Okay, and so this is like programming 4, okay, and compiler is programming 5. Programming 3 is algorithm and data structure. Data structure and the algorithm, right? At level 3. Programming level 2 is your OOP. programming level 1 is structured programming, knowing about if then else loop and function. So a full stack programmer need to know about front end, back end programming, right? And in terms of programming depths, you need to know about the beginning part, the loop. Okay, you need to write loop well. You need to be able to write your function well. That's the first step. And then next one, you need to know about how to design a class, and knowing about its a relationship, has a relationship, and then class static variable, okay, non-static variable, those kind of OOP issue, right? Third level, you need to know about stack queue, priority queue, tree, graph, those data structures, and then algorithms, right? Okay, those are okay. Next, we move on to the level 4. You need to know about how to translate from one language to another language. And then to implement it, it's level 5, your compiler design. So this is a core CS data study. And why this is so important, let's assume that, okay, you are going to work on AI, right? You're going to work on AI. And your AI is natural language processing. NLP, right? NLP. So one side is Chinese, and you do translation, and then this side is English. So what? So you're doing language translation. So you build Chinese language web, right? And you actually knowing about the grammar, a lot of things you need to qualify, whatever, and then eventually you need to generate English, Google translation, right? So what's that? What is this AI system? This AI system is a programming language translation system. It's a structure and the interpretation of computer programs, right? It's a core knowledge AI system, right? That's the term project we eventually work on. Let's look at another one. Another one here, the term project, I have a suggestion of single instruction runner. So that means this one means that I want you to write a instruction. So basically, there's a computer, there's only one instruction computer. Okay, whatever instruction that is. And then you need to translate your jump function, jump assembly jump, or your add, or your actually compare and greater than and jump, whatever. And then you may also have the move. These are the assembly. Maybe this one maybe is your 86 assembly, right? And then translate it to this. Again, this one is the language translator. So that is also a possible term project you can work on, okay? Now let's look at another one. This is another programming language example. Third one, this one called GeoJSON. Okay, GeoJSON is a JSON file. So JSON file is an object notation. So basically you write down a certain JSON format, right? Maybe a square, okay, maybe some SYG, whatever parameter, and it's actually in the JSON notation, right? And you translate, and it becomes square and in graphic mode, or a circle, or maybe this is a circle with some red color in there. This is again a language translation system. And it will be a good term project. Is okay?
Yeah, that's okay. Thank you.
And another one, someone actually don't want to do so complicated. Okay, Morse code. Whatever. Whatever. whatever most correct. Okay, and here you do translation into your English. That's an English translation, right? And you need to find out your your source language, your destination language, and then do translation. That it need to be so complicated. You must translate a scheme language. No, that's just an example. Okay, you think about something that you actually can work on yourself. Okay, one student, like maybe last year or a year before, design a AC condition language. So basically, this one is like a whole programming language to control a AC system. So when we set up the start the AC conditioner, when we start, and then when should actually the AC measure the outside temperature and whatever. So basically, he need to design his own AC machine. And that AC machine must have several functions, okay? Keep temperature or allow temperature to actually fluctuate it within certain range. Okay, start a heater, so whatever. There's a certain operation, okay, and then you do actually provide a language, describe the language well, and then use translating from Python to its AC language. Is that okay? Does that make sense? And that's also a term project. And do not to be too complicated, okay? Don't think about, hey, I must have the 300 instruction. Okay, no, we do not need that. Maybe this AC machine only 5 instructions or 5 operations. But as long as you can describing how this machine works and how you translate your Python or Java to it, how you use a Python Java to program it, that's it, that's good enough. You already demonstrate the key feature of programming language. Is that okay? We are not asking you to, hey, must give me a full-blown C++ compiler. No, that's the compiler course, okay? We are language translation course. Okay? Is that good?
Yeah, that's good.
Yeah.
Thank you.
So when you were doing that,
Hmm?
that GeoJSON one,
This
and
one you can start it now. It's a term project.
yeah, I mean, oh, can you hear me?
Yes, go ahead.
Oh, okay. So when you're showing the GeoJSON to square or circle,
You need to.
you're not expecting us to like make a graphics program that
No, you
makes a
need.
square or circle. You do
If
things.
you pick this project, you will need to show it. If you are working on this project, you will need to show it. Yes.
Oh, show a circle or show a square.
Yeah, like this.
Mhm. Graphically.
So there are more material you need to figure out. This is a project. So something like this you need to show. Is that okay?
Sure.
But I do not say that you have to do this project. No, this is only a candidate that you can pick. Okay. So basically your input is like this. So this one, if you work on this one, it will help your knowledge of what is a JSON format data, right? The other one is you also know about how this graphic can be shown. Your GUI knowledge will improve, right? Is that okay? But this is one candidate project. That means that you have to do this. Whatever I list down in the candidate project is only suggestion. It's not, you must pick from one of the 3. No. Any language is welcome. We are open project, okay? We are open project and term project. So if sometimes open project is even harder than the closed project. Closed project, you just, okay, there's a sorting, let me do sorting. There's nothing you need to worry, right? But open project is more challenging because you need to pick a good project and you need to, but the good thing is that later you will be more creative, okay? You will be more creative. Do not need to rely on people to give you something to do, right? And creativity is the key when you try to work on project or even start a company. Right? Okay, any other question? And when do you want to start it? Now, okay? I would say now. You can, there's no limit that you need to go to week 10 until you start to think about the proposal. No. You can think about a proposal at any time. Okay. And if your end result is different from proposal, that's okay. That's okay. In the middle, you can change the topic if you like. Okay. We evaluate your proposal and the project result separately. So you can get started for now. Okay. Let me see. Is there any other question? Usually I don't take the resubmission of the assignment unless that there is a special reason. Okay. Usually I don't.
Yeah, yesterday yesterday morning I submitted what I'd done like the previous day.
Mhm.
But then I realized like maybe one of my problems, it was like number 3 on the last homework. Like it didn't work if you had like a bigger dictionary.
Mhm. You
So
can send email, but
yeah,
I
so I
mean,
emailed you the updated version.
yeah. Okay, I'll take a look on it, but I cannot guarantee I will change the score. Okay.
Okay.
Sometimes depend on where you originally have and how much improvement you have. Okay. Okay. Any other question? And there are so many projects, so keep doing it. Okay, keep doing it. Any other question? Okay, if we run out of question, let's go back to. I'll just do overview. Okay, on this week's Python reference environment. Okay. So last time we talked about the data type, right? Data type. But data type is the definition of the memory associated with the variable name, right? That's called binding. There's a binding, but the binding changing over time. And then they are local binding, they are global binding, they are actually static binding, they are non-static binding, they are instance variable, so many different things. And it's called reference environment. Okay, so every language has its own rule for reference environment, and that's what we want to discuss in chapter 3. Okay, in chapter 3 is talking about its reference environment, and then how they work. Okay, so it's a name, scope, binding, and environment. Okay, so first you need to know about every single word precisely. Okay, and you know about the allocation of the memory, and then what is scope rule. Every language has different scope rule and the reference environment. Okay, so first thing is like name. I think variable name is pretty simple. You just have some ID, right? Binding is between the name and the memory. And because of what? Because of the local scope and global scope and different scoping, the binding can be changed. Okay, and I say binding is similar to marriage. Okay, so you have your marriage has some lifetime. The lifetime of your binding is called a scope. Okay, it's called scope. Okay, so you have local scope, you have global scope. And binding has 2 ways. One is static binding, the other one is dynamic binding. Static binding is that your binding rule is determined at the compile time. Okay, also it also sometimes called actually also called compile time binding, okay, or early binding. And recently, especially scripting language, they prefer to have the dynamic binding. But dynamic binding is you binding your data, your variable and the memory when you run it. So it's a runtime binding or static binding. These are two different rules. Okay. So for Java's instant variable, it's all dynamic binding. Okay. And C++ object and HM function, they allow dynamic binding and static binding, both. And they have a virtual binding. Okay. So when you see that C++ there's a virtual, is related to dynamic binding. Usually it's actually static binding. Okay. There's virtual function, virtual link. Okay. And those virtual things are basically late binding, dynamic binding. Okay. So this rule, I don't go into the detail, but you actually just knowing that these are two different binding at a particular time. As for Python is dynamic binding. Okay. So here you have different binding rule. Some of the binding actually right hand side is parametric method of binding is more for Java. Left side is parametric binding. This one is for variable inference. So this is more for JavaScript or Python, okay, on the left side. And there are different binding time and strong type, weak type. We talked about it before. Okay. So Python, okay, I'm sorry. Python is static scope. It's a static scope, but dynamic typing. So here you need to be careful about these two words. Static scope, but dynamic binding. This meaning different thing, okay? So when you do scoping, it's actually determined at the compile time. Okay, determined at the compile time. That's actually called statically scope. So what this means is you define a function, f function, there's a variable a. So this a scope, it will be a local variable to this f function. So if there's another a outside, this one is a global a. These two a are different. So this is called static scope. Static scope means that you, at the compile time, this scope already been determined. Okay, but binding is different. Binding is that when you run the program, whether this a is a local a or this global a, have to see where this a happened, and you will find whether it's actually is local a or global a. So that's the binding. So that associated with the memory, the association time need to look at the runtime. Okay, but the scope, this one, when you write it, it will be local variable. It's actually determined by the compiler. Is that okay? So must remember this one. Python is statically scoped by dynamic binding. Okay, so Python is a dynamic typed language. Python does not have any problem, even if we do not declare the type of variable. It stays, so the variable type is keep changing, right? And the variable location is keep changing. It's called dynamic binding, dynamic scope, it's dynamic typed, right? But the variable's scope will depend on where the variable has been declared. That's called statically scope. Okay, this one right now is just one sentence, but are very hard to understand. Okay, I know it's very hard to understand, but we will see some example later if we have it. Okay, there's a steady scope. Okay, same thing. C double plus is a steady scope. Okay. As I say, Python language is on top of C double plus virtual machine. So many things that is good for C double plus is also good for Python. Okay. Dynamic binding. Okay, this one. Namespace. So it's namespace. When we look at the scope, it has this LEGB rule. Okay, local enclosure, global, and binding. You look at its scope first at the local. Okay, and then enclosure, and then global, and then built-in. Okay. So one problem. What does this enclosure really mean? Anybody know?
Within a scope,
Yes. What does this enclosure really mean?
oh, I'm guessing that it's a variable within the scope.
Yeah, it's one scope, but what does this enclosure really mean? Okay, local we know it. Local we know. Local variable is f function, and we do have a. So this a is local variable, right? Global is actually okay. We do have a y outside of this f function, so this y is a global reference, right? Built-in is like default Python has a built-in variable such as len function that is a built-in, right? And what is enclosure? Enclosure is between global and the local. Right? That's because don't forget that your Python language you may have defined f function is one label, right? And you may have another function inside function. And function inside function may have another label of the function. So from certain enclosure label, this is one enclosure label. Is okay? And inside this function, there may be a for loop. And inside for loop, there may be a variable A. So that's local. That's really local. And the enclosure is any of the indentation label that create one enclosure. Does that make sense? Hello. So basically, Python you have many labels, right? Many enclosure indentation label. So this indentation label means there is certain enclosure. If there is an inner one, it's another enclosure. Is that okay? A local means that your current one you have in there. So if you have some definition here, it may not apply to the blue one. Blue one may not apply to the green one. You have to see where your variable is being defined. Is okay?
Yeah, that's okay.
Okay, so but anyway, this one is called LEGB. You look at the definition from your local first, and then enclosure, and then global, and then built in. Okay, same thing for JavaScript. It actually is also fit in using this one. Okay. Okay, so the purpose of the function has a modularity, abstraction, and code reuse, and it also create the enclosure. Okay. And if you want to know about which label it is, there's a Python tutor. So let's look at Python tutor, okay? Python tutor will teach you what enclosure they are. So this one called Python tutor, and in fact, they give you the different scope for Python stack, C++ plus Java. This main important language. Okay, it give you the different one. So let's look at Python. Okay, so let's assume that here we do have a define f function. Okay, a equals 3. Okay, and then print a. Okay, outside here actually a equals 4. Okay, print a. Okay, and then f function. Okay, and then this one is Python. So evasion. Okay, get started, right? Get started. And then we do next. Okay, create we have definition of a function, but we haven't called it yet, right? We haven't called it. This one just create a global frame. There's a function, f function. Okay, and then now we look at the a equals 4. So there's a variable a equals 4 created in the global frame. Okay, and next one we are going to print the global frame a equals 3, a equals 4. Okay, so the output a equals 4. Then we go to run the f function. So f function being called, and then you go into definition for a equals 3. So a equals 3, this 3 is a local A3. And you actually do, there's no return value. Okay, so it's inside A3. But outside A is still before. Okay, outside it's still before. And then we finish, we get out. Is that okay? So the dynamic binding means that this A, when you run, this A, you have to look at my local, I have definition, so I'm 4, I'm 3. So here I'm outside. So when I run this one, there's no local definition, so I'm 4. So this one, when you actually get the value for the binding, that's called dynamic binding. This is the definition for the Python. So this Python tutor has the advantage of being able to help you to look at the binding for these 4 languages. Is that okay? Let me post this Python tutor. I'm sorry. It's called Python tutor, okay? So this pythontutor.com. Post it to join if you are interested, okay? So this one you can look at the scope, okay? Different scope. And namespace, okay, namespace. Namespace actually is a module. Okay, namespace is a module. In C++, it's also called namespace, but in some other languages, it's called module. So a module means creating a certain scope, a certain scope. So sometimes you do. Okay, this one I have to talk about it. So namespace, each module, say I have a program called a.py. So a.py has its own module, its own namespace. b.py has its own namespace. Okay, so sometimes you do have import b. Okay, so import b. When you import b here, you may have an f function. Here you may have an f function as well. So this f function in a.py and the b.py are different functions, right? So if you want to run the b sub f function, you using import b, you have to run b dot f function. Okay, because your B's namespace and A's namespace are different, right? Sometimes you don't import B. If you don't import B, so you don't import B and you say from B import star. Then these two functions actually have collision. So when you define f function in here, you are going to run this f function. You can never run this function. Because the namespace, if you do this, the namespace of these two functions, these two modules merge together. So there is only one f function will exist. So see which one defined later. The later one will survive. Is that okay? So usually we do not encourage to do this from B import star, because once you merge two namespace, some of the variable will have collision. So usually when we have someone actually using the module, we prefer to use import, okay, numpy as NP. So as NP, we still need to use NP.array, but the namespace will not be merged. You will actually always say NP.array. But let's assume this is A.py. Your A.py is namespace and numpy's namespace will not merge together. So your A.py, if there is a length function, it still work. It will not be changed by the definition of numpy. Okay, but if you want to run the numpy's length function, then you have to do np.len. Then you can keep using this. Is that okay? That's the namespace merge and namespace. It's very important. It's also related to the scoping. Okay, but it actually is called functions and namespace. And when you import, you have to really understand which way you import. From B import star, it has one advantage that you merge the whole name, variable name. So you don't need to worry about which module or which function it is. So for small program, it works, okay? Small program, it works well. But if your program is really huge and you import 7 different modules into that, you will be in trouble. Why? You really don't know where your function has been changed. Then you are in big trouble. I would rather know that I'm running numpy.array or numpy.sort. I don't want we to know about, hey, my numpy changed my default sorting, that I had my own definition in my local program. Is that okay? So the change, the importing rule is very important, okay? Okay, next one, global versus local. That's assume this is easy, you know, okay? I just want to go through the key points, okay? Some of the things that you can study by yourself should be fine, okay? Here you do show you this different namespace and how it works, okay? And there is a so-called DIR to showing you the reference environment at that level. At that level. So you do DIR, it's a DIR of the environment when you are in the F level. Here you do DIR is the binding that you have at the global level. Is that okay? If you are interested in knowing about the attribute. So here we have A equals 6. We have some of the built-in whatever things here, right? We get out is totally different, okay? Your DIR is totally different. Okay, lifetime and storage management. Lifetime is the lifetime of available, okay? The lifetime of available depending on the storage class. So your local variable is in the stack. Your local variable is in the stack. Once your stack's frame being pop out, your variable is dead. Okay, then we say it's a local scope, and the lifetime is the binding time of your variable from the declaration to its dependent, the time of that we call it the lifetime. From the variable become valid until it's dead. Okay, that's a lifetime. And your local variable usually is when you push into the call stack until it can pop up. That's the lifetime. Okay, and then your object is actually when you create an object in your heap until that object being collected by garbage collection. That's the lifetime of a dynamic variable. Okay, and your static variable usually put into the constant pool, and it's always there until your program being terminated. So there are three major storage class. If you look at Java language, one is called local variable that actually is depending on its call frame. Okay. And then there's a dynamic variable that when you use new some object, those dynamic variable are as long as your lifetime of the object. Okay. And then if you are looking at the static variable is actually when your module being loaded, the variable will be there until your program terminate. Okay, that's three different storage classes. And in Python, will there be similar things? Yes, Python also has class variable, also has the local variable, also have those different terms. Okay. So they are, and Python also have meta class. And this is the relationship of the inheritance and the object type. Okay, these are more complicated. So I don't want to talk about a prototype. Okay, prototype is more than Python's object is more complicated than Java's object. Okay, Java's object is all by inheritance. And Python and the JavaScript is using prototype. So prototype means that at the runtime, you can add data field, reduce a data field based on your prototype. But this won't happen in Java. Okay. So that's the meta class that Python has. If you are interested, you can spend more time on it. But basically, this is different from Java. Sorry, let me get some water. This portion basically we don't test it. Okay, it's a little bit too complicated. So here, okay, it's actually some when available you just cell, there's a class point. And when you use a cell, these two variable X and Y are instance variable. So it belongs to the object. It doesn't belong to the class. Okay. So when this one show you this is a point, is a class called point. And you can create points, that's the this point P, right? So P would have your X and Y. These are instance variables. So instance variable, you use a cell, okay? In Java, we use this, right? And okay, and Python's class is more complicated than Java's class. Okay, so basically you have different type of variable arguments and return variables, local variables. Okay, these are argument and return variable and local variable. This exists in code stack. Okay, and they are temporary and bookkeeping one. These are local variables. When you have subroutine, you will call, and then there's a cobra. Okay. So stack and cobra, there's some calling sequence and termination sequence. We call it prologue and epilogue. Prologue is the procedure that you run to set up your cobra. Epilogue is the procedure to finish it up. Okay. And then so far these are the local variable. Okay. And for dynamic variable that you use new, whenever you use new or you use call constructor, these are trying to allocate the memory from the heap. Okay, and creating object. Okay. And this constructor and this constructor in different language for dynamic allocation can be different. In C language, it may be M allocate, memory allocate. When you give it up, it may be free some pointer. These are C language, okay? In Java language, you use new object and allocate the memory in a heap, okay? And once you have the garbage collection, it will be returned, okay? Unreferenced variable will be returned. And there are certain algorithms to find the fragmentation part and then to give you the allocation of the memory, okay? This is a memory allocation. And garbage collection is to, when you run your system for a certain time, garbage collection will be get started to clean up your memory. So for those unreferenced objects, if there's no one referencing it, those objects will be collected. Okay, but this one happened in Python language, happened in Java language, happened in JavaScript language, but C++ does not have the garbage collection. Okay, C# has the garbage collection. So this C++ lifetime of the object, you have to collect it by yourself. If you do not handle the lost object, then in C++ you will see those kind of things called memory lost. And then there are some tools to help you to analyze the memory lost. So that is actually some extra work to do. Okay. So these are the garbage collection rules. Scope rule is to see when the some binding is active. Okay, so you need to know whether right now is local scope or it's actually a global scope. It's called scoping rule. This is a little bit challenging. Okay, this scope rule. So they are dynamic scoping and the static scoping. To be honest, there are very few dynamic scoping because it's very difficult to trace. Okay, if there's some language still using dynamic scoping, I would say maybe, but very few. So most of the people actually just give up and using static scope. So static scope means that your scoping is determined by your function definition. When you write a program, you determine already. Okay, dynamic language, dynamic scoping, I would say they may exist before, but right now no language is doing that. Okay. So key points you need to know about reference environment and run those Python tutor well. Okay. This one, and there is a deep binding and shallow binding. Okay. Deep binding and shallow binding. Deep binding, shallow binding is the time you bind your variable. Okay, let's actually try to look at the deep binding. Okay, dynamic scope. Let's see. I don't have the example for deep binding. Okay, so deep binding in which choice is made when reference is the first created. Okay, this one I think I need to have some example. Okay, here I don't have example. Sorry. So next one is the meaning of the name within the scope. Okay. So you have a variable, say, when you have a variable may have something called pointer, may have something called reference, may have something called object. Okay, so my class, this actually is using C++ language. Okay, so my class, okay, my pointer, okay, there's a star. Star means body, okay, so the body of my language, of my storage, is my class. So I am a pointer. Okay, so my pointer is a pointer, it pointing to a certain object. Okay, this is called pointer. So the real data that you store is the object. Okay, and getting the reverse address is called the reference. So this one is a little bit complicated, that when you do C++, the pointer and the reference are different. Okay, pointer and different reference are different. In Java, reference is pointer, pointer is reference. So these two languages, when they define the reference and object, they are different. Okay. Okay, so one thing is you have to remember, one is address, one is the object, and two are actually reverse operation. Okay. And this one in Python, we do not have that. Okay, we do not have that. So here we have a name binding reference environment scope, scope of binding and scope. Here you need to remember this. Okay, I'm not trying to go into too deeply. Okay, let me see how much we still have. Let me see. So this one just some definition. Okay. Alias is reference. Okay, alias is reference. This happens when we have when we are in C++ language, we have the integer a, right? And we creating integer, okay, alias of b equals a. This means we create a associated with certain memory. B also pointing to the same memory. So A increase, B actually see the same result. It's okay. So when you see an alias B, means the name of the B actually is associated with A's alias. Does that make sense? C++ allow alias, okay? And there's some advantage of using alias to create usually when we do function, right? We do function, we do have an integer A, integer B, right? And we pass a variable to here. This one always what essentially called by value. You pass the 3 and 4 into there. But if you do a function call using integer alias A and integer alias B, this become a call by reference. This become a call by reference. Why? Because when you have outside you have x, y, right? And then here you have a function called f of x, y, right? So your x originally has some variable here, and your alias A is pointing to the same location. So A updated, your x also get updated. So that is actually called by reference. this is aliasing. It happened only on C double plus. We are talking about languages, so I want to explain this feature for you. Okay, when we have aliasing, you do see that the aliasing variable in C double plus, it is a call by reference variable. Okay, and C double plus allowed you to use the writing rule on the variable, and even return, you can return an alias. So you may see some C double plus function, it do return integer f these, okay? And that means the return value, A, you return the writing rule, the left-hand side rule to outside function. So once you actually say this one say you have a G equals F, right? Then this writing rule is the same as any variable that you return. So if you let G change, the other variable will also be changed, but you need to use it very careful, okay? And other language, you don't get that. You don't get that feature, okay? Environment, okay, this environment, we talked about it already. There's nothing I want to add too much, okay? You can study this different rule. Okay, you can just, here it just has the deep binding and shallow bindings explanation, okay? You can study this one, okay. Here there's one example of what is what's deep binding and what is shallow binding. Deep binding means that when you have more than one binding friend, you get the one that actually is deeper, okay? Shallow binding would be the closer one. So let's look at this Python code, okay? So here we have a definition of a function with parameter I and P, and there's an inner function called B function, okay? And there's a C function. So we call A1C. We call A1C, that's the main program. We call A1C, so we pass 1 and C to here, right? So this one is this I, so this was 1. So your function, B function, print 1, okay? And this is your B function. B function is a function within the A function. A function's body is over here. So when I greater than 1, we run the P function. So right now you actually call A1. So 1 actually is not greater than 1. You actually should be going to the else part. So else part you do call A2. A2B, 2B, you also what? You also pass the 2 and B together. But this B function is defined in A frame, not defined. This A function call, when you call it, is the B function is defined in A frame. Okay, then that's one result. If the B function I is defined by the another frame, then you will get 2. Okay, so this actually is a conflict whether it's a deep binding or low or shallow binding. Okay, so at the right concept is runtime stack and the reference environment capture the closure, showing us the dash box and okay. So when B being called, the parameter P and the 2 instances of I exist. Because of this closure, P was created in the initial invocation of A, so it's using the deeper one. So it actually, for the deeper deep binding, you get 1. Because that B, when this one call, the I is 1, it actually getting this one. Okay? Now the newer I equals 2. So this one show you the example of deep binding. Python is using deep binding. Python is not using shallow binding. The argument is this function, when we define B function, the I already assigned 1. That's the deep binding here, okay? So even though you go for call 1C and 1C main function, I actually not greater than 1, you call this quotient, and you call A to B. A to B, this B functions I is defined as its deeper part, not defined by the new B here, the new code. Okay? A little bit complicated. Any question? This is deep binding. Okay, you can try your Python to figure it out. Okay, it's just to study the deep binding. Okay, but that's the rule. Your definition is when you define it. Okay. Okay. And there is first class value. These are things are okay. Multiple environment. Okay, this portion I think I'll let you study, okay, until you find out. This one actually is just simple function code, okay. There's some simple function code and getting its reference value. And they are higher order function. I think I may need to talk about it some other time, okay? When we do functional programming, I talk about this currying and argument. I'll talk about it later, okay? Right now, this one probably too hard, okay? Higher order function, we can find some other time. Any questions so far? That's assuming that today we finish up to assuming we finish up to here, okay? We haven't finished this higher order function, okay? I'll try to talk about it next time, okay? Any question? This is a separate topic, so I'll need time to talk about functional programming. When we talk about functional programming, we'll talk about this, okay? Any other question? Okay, if no question, we will be ended here for today, okay? And then maybe see you next time for object programming. And we will talk about this higher order function when we talk about functional programming, okay? See you then. See you next time. Bye-bye.